In this video, we're talking about sampling distributions for means. And first we need to define the idea of a sampling distribution. Sampling distribution is when we take several small samples from a population and we calculate statistics for each. And putting all those statistics together gives us what's called a sampling distribution. And it's a sampling distribution because we're going to get slightly different values for each sample. So for example, if I want to find the average height of all students at Northwood University, I could randomly choose a class, measure the height of all the students in the class, and calculate the average. And if you remember from Chapter 8, this is a cluster sample because I'm randomly choosing a group and surveying everyone in that group. So for one class, I might get an average height of 5'9". And if I repeat the process, I'm probably going to get slightly different values. One class might have an average of 5'8", one class might have an average of 5'10". But a lot of them probably will be right around that same average of about 5'9". If I were to sample every single class and take the average of all the samples, I would get the population mean, which in this case is the average height of all students at Northwood. So what we say is that the mean of the sample means is equal to the mean of the original population. And we're going to see how we're going to use this in a second. So if I take a bunch of samples and take the average of each and then take the average of all those averages, then I will get the mean of the entire population. So we can also look at standard deviation. Remember that standard deviation measures how spread apart the data are. Now standard deviation is a little bit different because it's affected by sample size. So if I think about how likely it would be to get a value that's far away from the actual average. For example, it would be unusual to have a class of 10 students that had an average height of 6'5" because that's far away, pretty far away from the average height of the population. It would be possible if you just happen to have a class that had a lot of tall people in it. Maybe players on the basketball team are all taking the same class. It would be more unusual to find a class of 100 students with an average height of 6'5". That would require you to have a lot of really tall people that happen to be taking the same class, and it would be much more unlikely than having a class of 10 students. So as your sample size increases, your odds of getting something that's far away from the mean decreases. And that gives us this formula for standard deviation. Standard deviation of a sample is the standard deviation of the population divided by square root of the sample size. The n is I don't think it's written on here, but n is the sample size or the number of people that you are sampling. And we have this theorem called the central limit theorem. It says two parts. First, if the population is known to be normally distributed, sample means will also be normally distributed for any sample size. Even if it's not normally distributed, could be skewed left, skewed right, or something else, then sample means will have an approximately normal distribution as long as sample size is large enough, which we normally consider to be greater than 30. So what this means is that I'm going to use the normal distribution in calculating things in Minitab, even if I don't know if the population itself is normally distributed, as long as I have a sample size greater than 30, which in these problems is generally what we're going to have. So the first example here, we're calculating the mean and standard deviation. So we have the mean number of hours of television watched per week is 10.5 hours and the standard deviation is 3.6 hours. If we take samples of 16 students, we want to find the sample mean and sample standard deviation. So sample mean is always really easy. It's exactly the same as the population mean. So I just need to identify what number that is. In this problem, it is 10.5 hours. Sample standard deviation is only slightly more difficult. I use the formula sigma divided by square root of n. My sigma is 3.6, and my n in this problem, my sample size is 16 students. So my n is 16. So 3.6 divided by square root of 16 is 3.6 divided by 4, which is 0.9. The next problem, we're going to calculate probabilities, and we're going to use Minitab for problems where we're calculating probabilities. Calculating mean and standard deviation, you're going to do using the formulas. So this says IQ scores are normally distributed and have a mean of 100 and a standard deviation of 15. Find the probability that a randomly selected person has an IQ score greater than 105. So this is a problem that we did in Chapter 7. So we have mean of 100, and we have standard deviation of 15, and we're looking at greater than 105, which means we're going to do a right tail, and x is going to equal 105. So I'm going to pull up Minitab. And use the probability distribution plot like we've been doing, display probability, select normal, enter my mean and standard deviation, choose right tail, specified x value of 105. Click OK, and it looks like my probability is 0.3694. Question 3. If 4 people are randomly selected, find the probability that their mean IQ score is greater than 105. So the difference between this question and question 2 is instead of 1 randomly selected person, now I have 4 people. So that's my sample size. My mean is still 100, but my standard deviation is now 15 divided by the square root of 4. And since the square root of 4 is 2, that's 15 divided by 2, which is 7.5. Still a right tail, and I'm still using x equal 105 because I want to know the probability that the mean IQ score is greater than 105. So pull up Minitab. And enter in the same values, except for standard deviation is now 7.5. Now notice for this one, the probability is going to be a little bit less, 0.2525. So if I have a larger sample, the probability that they all happen to have a mean IQ score greater than 105 is going to be less. Question 4 says if 100 people are randomly selected, find the probability that their mean IQ score is greater than 105. Now this is a much larger sample, and so the probability that their average is going to be that far away from the mean is going to be a lot less. So my mean is still 100. Now my standard deviation is going to be 15 divided by square root of 100. So 15 divided by 10, which is 1.5. I'm still doing right tail, and I'm still doing x equals 105 because I want to know probability that the mean IQ score is greater than 105. So mean is 100, standard deviation 1.5, right tail and x value of 105. Now, this is significantly smaller. This probability is tiny, 0.0004, less than 1% chance that the mean of the group is that much higher than the mean of the population. So that's that probability. As always, pay attention to where MyStatLab is asking you to round numbers. And if your standard deviation doesn't come out as nicely as these, sometimes if you're dividing by a number that's not a perfect square, you're going to get a decimal. Try to include at least, I would say, 3 to 4 places after the decimal point. If you don't report the standard deviation in Minitab accurately enough, then it's going to possibly mark your answer wrong in MyStatLab if it makes the answer off just a little bit. So pay attention to where you're rounding. Like I said, I would say to go 3 to 4 digits after the decimal point when you're putting the standard deviation in. And lastly, we're going to recap using Minitab in these problems. So if you're given number of trials and probability of success, that's a binomial problem. So you need to use the binomial distribution. If you're given a mean and a standard deviation, that's a normal distribution problem. If you're given mean and standard deviation and a sample size, then you need to make this correction to the standard deviation that you put in Minitab, using the formula of taking the standard deviation and dividing by the square root of the sample size.